Now we start the exercise. How to find a residue? Question 1. Find the residue of the function f of z equal to z cube over z minus 1 4, z minus 2 into z minus 3 at z equal to 1. At z equal to 1 is the pole of the function of order 4, because when we put z equal to 1, we get the z infinity. Total z become infinity. And we say that at z equal to 1 is the pole of f of z as of order 4. Because of this power, we say the order is 4. If here it is 3, the order will be 3. If here it is 2, the order will be 2. Because of this 4 is the order of the pole. So we discuss here f of z equal to this, the given function. To find the pole, we use the substitution method. We put t equal to z minus 1, value of z is equal to 1 plus t. So here we put in place of z minus 1 there is t. Put t equal to z minus 1, z equal to 1 plus t here, z minus 1 equal to t, this become t raised to power 4, and this become t minus 1, and this become t minus 2. Now we take these two terms and to form it as a numerator, this become 1 by t4, and expand this term 1 plus t cube, this is 1 plus t cube, the expansion of 1 plus t cube, and these two terms we take them as a numerator. Now after expanding these terms by using the balance series and after simplification, this value become 1 by 2, 1 plus 9 by 2 plus 21 by 4 plus 15 by 8 into 1 by t. The coefficient of 1 by t is 1 by 2, 1 plus 9 by 2 plus 21 by 4 plus 15 by 8, this become 101 over 16. So the coefficient of the residue is, so therefore the residue is 1 by 101 over 16. This is the value of the residue, because this is the coefficient of 1 by t. This is a negative power, as we discussed in the direct series. The coefficient of negative power is the residue of the function. So the coefficient of 1 by t is 101 over 16. This is the residue of the function. Now question 2, find all singular points and corresponding residue of the function f of z equal to 1 by 4 plus z square. So we can write 4 plus z square as 4 plus 2 iota into 4 minus 2 iota. The function, this implies the function is not analytic at z equal to plus minus 2 iota. When we put here the coefficient of 1 by t is 1 by 2, 1 plus 9 by 2 plus 21 by 4, 15 by 8 equal 101 over 16. So this is the coefficient of 1 by t. This is the negative power of t. The coefficient of negative power of t is 101 by 16. So this is residue of the function. Now question number 2, find all singular points and corresponding residues of the function f of z equal to 1 by 4 plus z square. We can write 4 plus z square as z plus 2 iota into z minus 2 iota. The function is not analytic at z equal to plus minus 2 iota. When we put here 2 iota, this z becomes 0, and where here put minus 2 iota, this becomes 0. So total z become infinity at z equal to plus minus 2 iota. So f of z has singularity at 2 iota and minus 2 iota, and also it has pole at 2 iota and minus 2 iota of order 1. Because power of this term is 1 and this has also power 1, so we say that it has simple pole at 2 iota minus 2 iota. Now to find the residue, we use this formula. Residue of function at 2 iota, in place of n, we put n is equal to 1, this will become 1 minus 1 factorial d and 1 minus 1 dz 1 minus 1, and z minus 2 iota 1 over z minus 2 iota into z plus 2 iota at z equal to 2 iota. So this becomes 0 and this also becomes 0, and this is 0 factorial and this becomes 1. So after simplification, this becomes 1 by z plus 2 iota, and we put here the value of 2 iota. This becomes 1 by 4 iota. And multiply divided by iota, this becomes iota square minus 4, this is minus iota by 4. This is the residue of the function at 2 iota. Now residue of the function at minus 2 iota, again we put here in this formula z equal to 1, and this becomes, after simplification, as in this part, this becomes minus 1 by 4 iota. At minus 1 is iota square and this is iota by 4. Now question C, find the singularities and residue of the function f of z equal to cos z over z to the power 6. The function is not analytic at z equal to 0, so it has singularity at z equal to 0 and a pole of order 6. Due to this power, this has pole of order 6. So again using this formula, we put n equal to 6 in the place and 6 minus 1 factorial, and this d 6 minus 1 dz 6 minus 1 z minus 0 to the 6. Value of z is cos 6 over cos z over z ki power 6. This becomes 5 factorial and this is d5 over dz 5, and these terms will cancel, and cos z. Now we are applying the limit when z equal to 0. The fifth derivative of cos z equal to minus sin z, and when we put z equal to 0, this total z becomes 0 due to sin 0 equal to 0. Now question 4, find the singularities and residue of the function f of z equal to z square plus 1 over z square minus z. The function f of z equal to z square plus 1 over z into z minus 1. We can write this function as z into z minus 1. Since the function is not analytic when this term equal to 0, so we say we have the value of z equal to 0 and 1 be the singularity of the singularities and the poles at 0 and 1 of order 1. Here the power is 1, so we say that it's order 1. Now using the formula, we find the residue of the function at 0. 1 by n minus 1 factorial, n is equal to 1, so this is 1 minus 1 factorial. In place of n, we put 1, so this becomes d1 minus 1 over dz, 1 minus 1, z minus a, the value of a is 0, so this becomes z minus 0 to the 1, this is value of z. This term will cancel and we get the z. 1 by this becomes 0 factorial, and this becomes d0 over dz 0, this one derivative we eliminated. 0 factorial is 1, and here we apply the limit when z equal to 0, 0 plus 1 over 0 minus 1. So total this term minus 1. So this is the residual function at 0. Now you find residue at z equal to 1. Again residue of the function 1 by 1 minus 1 factorial d0 over dz 0, z minus 1, z square over z into z minus 1. So these terms will cancel, and apply the limit when z equal to 1 here, this becomes 1 square over 1. So this becomes 2. So 2 is the residue of the function at 1.